to the problems video on the section entitled Application of Multiple Integrals. So this is the one where during the concepts video I mentioned that I wasn't going to really be explaining any new concepts because in this section you basically just apply what we've learned so far with the help of a few extra formulas from a certain page in your textbook. So anyways, I'll be doing a couple problems from here. So the first one asks us to calculate the total charge, and this is, I guess, electric charge we're talking about, the total charge of a solid ball, and the volume is given by x squared plus y squared plus z squared is less than or equal to 5. So in centimeters, apparently, assuming a charge density of the following, and then we have they give it to us in row of x, y, z equals 3 times 10 to the negative 8, and then x squared plus y squared plus z squared all to the 1/2. Even though they give it to us with this row, that could be any variable, really. I don't know why they gave it to us in that, because that's really confusing, because that's actually going to be a variable used in our calculations. So I'm just going to rename it capital F. And you can do that. It's just a function name. So anyways, this is our given function in terms of x, y, and z. So what we're going to be doing here is utilizing spherical coordinates, and we can tell because we have 3D. This is a three-dimensional thing with 3 variables, and they already give us lots of x squared plus y squared plus z squareds. So remember how I said there's a relation between this expression and rho squared, right? So already we can see that rho squared, we can plug in rho squared here, right? So f of x, y, z equals 3 times 10 to the negative 8. And then instead of, well, I'll just rewrite it here and then I'll show you what I'm going to be subbing in instead. So if I plug in a rho squared for this spot, then I'll have rho squared to the 1/2. So that just turns out to be rho, right? So f of rho phi theta is equal to, and this is just a number in front, so some constant times rho. Okay, so that actually simplifies things a lot. But anyways, other than that, so that's our function in terms of our spherical coordinates, and we also need the bounds, right? So for the first one, we can utilize the given information here, right? This is the only piece of given information, but it does say a solid ball. So that means we're considering the whole entire sphere, all the way around, okay? Not like half of it or a quarter of it or anything. The entire sphere. So what we can do here, though, is replace x squared plus y squared plus z squared with our handy-dandy rho squared, less than or equal to 5. And again, just as a reminder, rho represents our spherical radius, not the one, not the radius on the xy plane, but the spherical one. So this is a 3-dimensional thing. This measures the radius in 3 dimensions. Anyways, so, and rho always has to be greater than or equal to 0. So anyways, when you square root to solve for rho, then we get 0 is less than or equal to rho is less than or equal to radical 5, square root of 5. Okay, so these are the bounds for rho. We just found those. And also, now we need phi and theta, okay? And also, here, they don't give us any information about these angles, or the bounds for these angles, because they already told us solid ball, which implies the entire sphere, which we should know the bounds for the angles already. So we know that phi measured from the top, right, So let's say we have our sphere, and phi is measured all the going down this way. Sorry, that was a really bad drawing. Hold on. So let's say we have something like that, and phi is measured from the top. So let's say phi is going this way, right? Or it could be going this way too, whichever way. I just go to the right because I'm a righty. But anyways, so phi goes from 0 to pi because we want to cut out one slice of it. Okay, one paper thin slice of the orange. And then theta allows us to rotate it around the z-axis. And we're going to go all the way around. So that would be 2 pi. Okay, so these are our bounds. So we have all of that. And we have our function in terms of spherical coordinates. And then we also have, we know that dv, so our differential volume, is going to equal rho squared sine phi d rho d phi d theta. So we've done that before. So I'll set it up on the next slide. So we have the theta bounds, so 0 to 2 pi. So that's for our d theta. And then our phi bounds go from 0 to pi. So that's d phi. And then we have our rho bounds, which are from 0 to radical 5. Okay? And this is d rho. And then our Jacobian, right? The change in volume when you do change of variables. That's that. And then the last thing to plug in here is our function in terms of spherical coordinates, which we found to be, we still had to put this constant, right? And then it was times rho. Okay? So this is the setup for the entire integral. And now we just solve through, basically. So we'll take this, and then at this point we can combine these two rows, right? That becomes rho to the third. And then as you can see, because we have constant bounds, this is an iterated integral. So I'm just going to bring this constant all the way to the front, just to get it out of the way until the end. So something like that. And then I'll put all the thetas first. So then we'll have from 0 to 2 pi, and nothing in here inside the integrand is theta. So I'll just write a 1 d theta, right? And then we'll do phi's next, so from 0 to pi. And then the only thing with phi is a sine phi, so d phi. And then the last thing is 0 to square root of 5. And then we have a rho to the third, d rho. Okay, so let's start calculating the rest here. So we have theta going from 0 to 2 pi. And here we have, this is a negative cosine phi, right? And this goes from, phi goes from 0 to pi. Okay, and this last one here is 1 over 4 rho to the fourth, 0 to square root of 5. All right, and we'll just continue here. 3 times 10 to the negative 8th. And this is 2 pi minus 0, which is just 2 pi. Oh, forgot a parenthesis. And then we have minus cosine pi minus a minus, so plus, cosine 0. And then at the end we have 1 over 4 and radical 5 to the fourth minus 0. So just that. And then 3 times 10 to the negative 8. And then our 2 pi. And then this here turns into negative 1. So that's 1 plus 1, which is 2. And then a 1 over 4. And this is times 25. Okay? So basically, the 2's here cancel, both of those 2's cancel with the 4. And we get 75 pi times 10 to the negative 8. So that ultimately turns out to be something like 2.36 times 10 to the negative 6 C, which stands for, it's just a measurement of electrical charge. So anyways, that's just not important. That's more physical stuff having to do with physics. But anyways, this is our answer. So ta-da, kind of a thing. All right, so let's get started on the next and last example for this section.